Hey guys, so welcome to the first lecture for trigonometry. So let's have a look at the very first question. It says the north and south buildings are 100 meters high and 75 meters high respectively. From the top of the north building, the angle of depression to the top of the south building is 20 degrees. How far from each other are the two buildings? Okay, it is absolutely vital, guys, that you draw this information out in order to be able to answer this question. Okay, so let's draw this out. So we have the south building, let's call it the south building, which is the small one here. We'll call that S. And we have the north building there. Okay, so now the north building, as it says, is 100 meters high. So that whole thing is 100 meters. While the south building is, I believe, 75 meters high. Now, the other piece of information that's been given to us is that from the top of the north building, the angle of depression to the top of the south building is 20 degrees. So let's do that. So we have an angle of depression there of 20 degrees. So if I was to extend this out, this would also be 20 degrees. Now, the question says, how far from each other are the two buildings? So this is the distance that we're looking for. So if I was to draw this out, so we have 20 degrees there, and we have this distance there, which is basically the distance between the north building, between the height of the north building and the height of the south building, which is simply 100 take away 75, which gives us 25 meters. And this is the distance we need to find, which is the distance between the two buildings. Now guys, again, using our so, ka, and toa concept, let's see what we have to work with. So we have the angle here, we've been given the adjacent side, and we have been given the opposite side. So we are simply going to be having to use the toa concept. So tan of 20 degrees is equal to the opposite side, which is 25 in this case, divided by the adjacent side, which is x in this case. Then, using a little bit of transposing, we have x times tan of 20, which is equal to 25. And then finally, rejigging this, we have x equals 25 over tan 20 degrees. Then, if I was to put this into the calculator, I get a value of 68.7 meters. So, how far from each other are the two buildings? The two buildings are 68.7 meters apart from each other. Fantastic. Let's move to the next question. Okay, so this particular question says, Sam is preparing for her upcoming run for the charity she's supporting. She usually just goes for a run around the park near her place, which is 350 meters by 350 meters. Now, she usually runs 6 times around the park when she's training. How far? However, this morning, she's not feeling too well, so she decides to only run 2 of the sides plus the diagonal across the park. If she does this 4 times, how much less does she run compared to her usual training? Okay. So again, guys, it's really important that we draw out exactly what's been given to us. So we have a squarish park, which has sides of 350 meters. She usually runs 6 times around the park. Okay, so she does, this part here. Oh, let me use a different color actually, so it stands out. So she runs this, and this, and then she does that 6 times. So as you might have already guessed, we're simply looking at the perimeter here. So the perimeter of the park is simply 350 times 4, which in this case is 1400 meters. Now, she used to do this 6 times. So the amount she would run, so total, usually, I'm just going to call it usually here, so we know what we're working out, is 1400 multiplied by 6, which gives us a total of 8,400 meters. So she usually ran 8,400 meters. However, what she's done today is that she's not feeling too well. So she only runs two of the sides. So I'm going to use a different color again. So she runs, let's say, this side and this side. And then she runs the diagonal. So she runs that diagonal bit there. So she's basically running that triangle, and she does that 4 times. And as you might have guessed, guys, we don't actually know what this diagonal is. So we need to work it out using, yep, you guessed it, Pythagoras' theorem. So that's C, that can be A, and that can be B. So let me draw this triangle out so it's a little bit more clear. So that's 350, that's 350, and let's call that C. And that can be, I think we call that B, and we call that A. Okay, so we have A squared plus B squared equals C squared. So we have 350 squared plus 350 squared is equal to C squared. Okay, so C squared is equal to 245,000. And then squared taken to the other side, we have C is equal to square root of 245,000, which is approximately 495 meters. I'm just rounding this up to the nearest a whole number. Okay, so she would be running 350 plus 350 plus the diagonal now, which is 495. So every time she did that lap of that triangle, she would get a total of 1,195 meters. Then she would do this 4 times. So 1195 times 4 gives us 4,780 meters. So this is how much she ran on the day she wasn't feeling too well, while this is how much she usually runs. So the difference between the two, so 8,400 minus 4,780, which gives us a value of 3,620 meters, is the amount that she runs less compared to her usual training. So I'm just going to write the value up here. So 3,620 meters is how much she runs less compared to her usual run. Okay, let's move to the next question. Okay, so this question says, Dolly is riding her bike around the area. She rides 6 kilometers north, then 4.3 kilometers east. She then rides 2.4 kilometers north and 1.6 kilometers west. From there, she rides back to where she started in a straight line. Show that she rides a distance of 23.12 kilometers altogether. Okay, so let me just quickly draw out a compass here on the side, just so we are completely aware of what the different sides are. So we have north, south, east, and west. Okay, so now what we need to do is simply map out the exact journey that she followed here. So she first traveled north for 6 kilometers, that's what it says there, and then she traveled 4.3 kilometers east. So 6 kilometers there, and then 4.3 kilometers east. Then she rode 2.4 kilometers north, which is 2.4 kilometers there, and then she rode 1.6 kilometers west. So 1.6 kilometers west. From there, she rides back to where she started in a straight line. Okay, so now I'm just going to draw out using a different color. So right there. So that's right there is the amount that she traveled straight back to her original point. The question says, show that she rides a total distance of 23.12 kilometers. So I'm just going to use a different color here just to map out that we are indeed looking at a triangle. Okay, so the total distance that she rode was she rode for 6 kilometers, then 4.3, then 2.4, then 1.6, and then we need to figure out what this blue distance is, and we'll be able to figure out what she rode altogether. So first, let's figure out what the distances we already know. So we have 6 plus 4.3 plus 2.4 plus 1.6, which gives us 14.3 kilometers. Then let's figure out what this blue distance is. So let's draw out this triangle separately. And I want to use the blue color just to signify the point we are trying to make. Okay, so we have 6 kilometers this way, and then another 2.4 kilometers north. So this part will be 8.4, while this part here would be the difference between the distance that you traveled east, which is 4.3, and the distance that you traveled back west, 1.6. So 4.3 minus 1.6 gives us 2.7 kilometers. Okay, so again, using our different colors, we have A here, B there, and C there. So using Pythagoras' theorem, we have A squared plus B squared is equal to C squared. A squared is 8.4 squared, plus B squared is 2.7 squared, which is equal to C squared. Therefore, C squared gives us a value of 77.85. Therefore, C is equal to 8.82 kilometers. So if we add up 14.3, which is how much you wrote earlier, and then 8.2, which is the distance that you wrote straight back to the original point, we get a value of 23.12 kilometers. So we know that she indeed did write a distance of 23.12 kilometers altogether. Fantastic. Let's move to the next question now. Okay, so this particular question says, while water skiing, Renier travels over a ramp that rises 4 meters above the water level and spans a horizontal distance of 11 meters. What angle does the ramp make with the water? Okay, so let's draw this out. So we have the water here. Let's say that's the ramp, which is 4 meters above the water. So that part there is 4 meters. Then it says that it spans a horizontal distance of 11 meters. Now the question asks, what angle does the ramp make with the water? So that's the angle that we're looking for. Let's call that x. Now once again, guys, using our concept of SOHCAHTOA, I'm hoping that you guys are fairly used to this concept by now. So we have opposite and adjacent. So we again have to use TOA. So we have tan of x is equal to 4 divided by 11. Therefore, tan of x is equal to 0.364. Now, taking the tan over to the other side, we have x is equal to inverse tan 364, which gives me a value of 20 degrees. Therefore, the ramp makes an angle of 20 degrees with the water. Simple as that. So guys, that brings us to the end of the first edition of, or the first lecture for trigonometry. Please make sure you go through this lecture a couple of times if you need to really understand the, how to apply the Pythagoras theorem as well as using the SOHCAHTOA concept. In the meantime, I will see you in the next lecture for trigonometry. Thanks, guys.